Hello students, welcome to Aarush Coaching Classes, and let's continue with the redox reactions of class 11th part 2. Ask you to take out the oxidation state of sulfur in H2S4O6. Will you try this once?
Okay.
Okay. See, plus 2 and minus 12 will be minus 10, so this will be plus. Okay. Yes, but we do is when you get an oxidation, do you think an oxidation state can be like this?
No.
No. Why? Because this kind of oxidation state is known as average oxidation state. Now, why do we call like this is, we will draw the molecular diagram for this, and then I will explain you that why it is called like this. So, how many sulfurs? 1,
4.
2, 3, and 4. Correct?
Yeah.
And when I draw them, it has to be like this because oxygen is 2. Correct? Yes?
Yeah.
So how many oxygen? There are 6. So
6.
1, 2, 3, and 4 oxygens are done. What about the rest? It will be like this. OH, ONH. Correct. So now if you observe carefully, if you see this, what is happening here is we are getting an oxidation state of, see, sulfur is 1, 2, 3, 4, and 5. So 5. What is the oxidation state of this? 0. Oxidation state of this sulfur 0. And for this again 1, 2, 3, 4, and 5. It is like this. Very typical questions. They do ask in exams also. Although it is like high level, maybe school exams they don't ask, but yes, you should be knowing. So when you do, like when it comes in exam and people take out this, they give you wrong. Why? Because it is considered average oxidation state. And in this case, you will have to draw the diagram of H2S4O6 and then take out these states. Got it?
Yeah.
So you find it tough or easy?
It's okay.
That's okay. So Swapna, it is not that tough. You just have to remember like few ones. Like, okay, this one is little typical. So you should remember these kinds of questions. Okay?
Yeah.
Let's move on to the next one. Can you take out the oxidation state of Fe? What is Fe?
Iron.
Yes. In FeO. Can you do this quickly?
Is it 2?
Yes, you said it correctly. It is 2. Why? Because this we knew x minus 2 equal to 0 and x equal to 2. So when the oxidation state of iron is plus 2, it is called ferrous oxide. Okay. Same thing, okay. If I ask you to take out the oxidation state of Fe in this one, Fe2O3, then what will be the oxidation state?
3.
Superb. Why? Because you will write it like this, 2x minus 6 equal to 0, which is equal to 3. So when sulfur has, iron has an oxidation state of plus 3, it is called ferric oxide. Understood when to use ferrous? When to use ferric?
Yep.
So when it is plus 2, you will call ferrous oxide. When it is +3, you will call ferric oxide.
Ferric oxide, yeah.
Correct?
Yeah.
Let's try in another one. Fe in Fe3O4. Now can you take out the oxidation state?
Minus A over 3. I mean A over 3, not minus A over 3.
Yes. So you said 8 over 3. And what I told you?
Is you have to draw it.
Yes. Because it is again called as
Average oxidation state.
Super. So in this case,
Right.
what we will do, we will split this. How we will split this? We will make it FeO dot Fe2O3. What we did, we have split in these form, FeO and Fe2O3. Okay. So we have split this. We have written, see, Fe is 3, O is 4. Correct?
Yeah.
So in this case, what is the oxidation state? +2. How do you know?
Yeah.
You know it from?
Yeah, from before.
Okay. And in this, we have the oxidation state as
3.
+3. That means it is a mixed oxide.
Wait, so all of them with fractions are just called mixed oxides, or is it just in this case?
No, this is mixed oxide. Why? Because FeO and Fe2O3. When you see this one, this was not a mixed oxide. Here you were getting different states. But here we have splitted this into ferrous and ferric. You can also call this as ferrous plus ferric oxide. So instead of taking a long name, ferrous plus ferric oxide, you can directly say it is a mixed oxide.
Okay.
And Swapnev, these kinds of questions do come in exam because they are tricky. Fe3O4, people get confused. They get 8 by 3. Obviously, the answer is wrong. So you should know how to split and tell them it has 2 oxidation states because it is made up of ferrous plus ferric, and hence it is called a mixed oxide. So it will have +2 and +3, both the oxidation states.
Yeah.
Correct?
Yeah.
Another example like this. Let's try the oxidation states of bromine in Br3O8. Can you try this one?
Wait, how do you tell if it's a mixed oxide or not without splitting it one by one?
How? You cannot tell that. See, in ferrous or in the iron state, it was possible. But in this, is it possible?
I'm not sure. I don't think so.
Yeah, not sure. Because these kinds of things, you will have to draw the molecular structure and then take out the states. Because now you would be knowing that X will be how much? 16 by 3. Why? Because this is X, this is -2. So 3 into X will be 3X. 8 into 2 will be -16 equal to 0. So X becomes 16 by 3. Correct? Which is wrong. Or you can say it is the average oxidation state. And now do you think can we split this into like this one? No, not possible. Then what we'll do? We will make something of this sort. How will you make it? Swapnil, How will you make this?
By drawing it.
Like this, Br3O8. How will you make it? See, X we will get is 16/3, which is wrong. So see, 3-bromine. So you will write Br, Br, and Br. Correct?
Mm-hmm.
So oxygen. One, two, three, four, five, 6.
Mm-hmm.
And we need 2 more. So 7 and 8.
So when you're drawing the oxygen, you always need the double bond.
Yes, oxygen will be double bond.
Mm-hmm. Okay.
Why we did over there in this sulfur one? Because here it was hydrogen attached. So this 2
Okay.
oxygen like this went here.
Yeah, one of the bonds are with the hydrogen.
Okay. Yes. So
Okay.
that's the reason. That's the reason I've drawn there that way. But here oxygen is always 2, -2 now.
Okay. Yeah.
Okay. So now if you see the states, can you tell me the states of bromine now? In this, what it will be? 1, 2, 3, 4, 5, and 6. 6?
Yeah. 6.
In this, it will be 1, 2, 3,
4.
and 4.
6,
4,
4, 6.
So this will be the state. Correct?
Yeah.
So you have to remember the tricky ones. That H1 wala, this iron one, this bromine one. Okay, as soon as you see this in the fraction, either it has to be a mixed state or you have to draw the molecular formula, I mean molecular diagram, and then define the states. Correct?
Mm-hmm.
Okay. Let's try one more. Let's see. Pb3O4.
Okay. PB. Is it 404?
How much?
404.
404.
Yeah.
Are you sure?
Not sure.
Okay. So although you tried to draw the diagram, but see, in these case, what you can do is when you are drawing PB, PB, and PB, you can see like 1, 2, 3, 4 oxygen. You cannot, I mean, you can, from the diagram itself, you'll come to know that, okay, molecular structure is not possible. So it is a mixed oxide. So how it is a mixed oxide?
Yeah. So if you can't get like a molecular structure,
so
then
some common sense we'll have to use it. Yes, otherwise what will happen? We'll get confused. So in this case, if we go, it will be like 3x minus 8, which will be x equal to 8/3, which is not possible. So what will I do? I will make like this PbO dot Pb2O3. Correct?
Yeah.
So obviously, same way in the iron, it was +2. Same way here also it is +2. And here it is +3. Correct?
Yeah.
+3. Okay.
Mm-hmm.
So generally, iron one comes more in exams. But if you get this one also, you should be able to do it. Correct, Swapnil?
Mm-hmm. Yeah.
Yes? Okay.
Yeah.
Let's try another one. So why am I doing so many, Swapnip? Because these kinds of questions you will get in exam. You will not get those theory questions. You will get 1 mark, 2 mark questions like this. Then what will you do? Okay. And I'm not sure if you're preparing for the competitive exams also. So even if you're doing that, you will, get these kinds of flavored questions, styled and all.
Yeah.
Anyway, so can you tell me S in H2SO5?
Okay. Is it 8?
Oh, you said it 8. Why? Because X plus 2 minus 10 equal to 0, and hence Swapnip said that X is equal to 8. Okay. Fine. Answer you've taken out correctly, but actually the answer is wrong. Why? Because sulfur belongs to which group?
I forgot.
Yes, dear, come on.
I forgot.
Okay, rule number 6. Can you repeat rule number 6? What was the rule number 6?
I don't have the rules in front of me because I don't have the book.
Okay, I will tell you. Rule number 6 was oxidation state of halogen is -1. Correct? Yes?
Yeah.
But they show variable oxidation states, as in chlorine. Chlorine used to show the oxidation states from +1 to, you can say, +7. So that means, -1 to +7. That is -1, 0, 1, 2, all states it can show. Correct? Same way, rule number 6 only I told you, P block elements. What are the P block elements? Nitrogen, sulfur, and chlorine. Correct? So these also show the variable states. Like nitrogen shows from -3 till +5. Oxygen shows -2 to +6. And chlorine is -1. Swapnil. Sulfur can have maximum oxidation state up to only 6. It cannot have it till 8. I told you rule number 6 you will get maximum questions from. Very important rule. Okay. Just check your notes. If you don't get it, what I'll do is I'll take a screenshot of my this thing or scan my notes and I'll send it to you. Okay?
Okay.
All right. So this was your rule number 6. Rule number 6, where I told you clearly that P block elements show the variable oxidation states, that is nitrogen and sulfur. And sulfur can show the maximum state up to +6. But because group numbers are till 10. Yes?
Yeah.
So then in that case, what we will do? So I will do it once again for you, otherwise you will get confused. SO5, oxidation state is X is 8, which is wrong. Why? Because sulfur's maximum oxidation state is till 6.
Yeah.
Okay. So what we will consider, how we will take this now? We will consider oxygen in which form? In peroxide form.
Yeah.
Yes. So this, how will I make S? Then I will take 2O, this 2O. Correct? So 2 O's are done. Now I want to make 3. Peroxide, how do you make it? Like this. Okay. And here I have H.
Yeah.
So here if you observe, what will be the oxidation state of sulfur? If you observe carefully, it will be 6. See,
How
1,
come
2,
there is
3,
only
4,
4
5,
O's?
6.
How
No, I
come?
think, wait. 1, 2, 3, 4. How many I've made? 4. We need to make 5. Sorry, I
Yeah.
did one mistake. Sorry. That's okay. All right. Here I need to make like this. Okay. Now it's okay. 1,
Yeah.
2, 3, 4, 5, and 6. Correct?
Yeah.
That means you have to assume that it is in which form? It is in the peroxide form. That means when you will write it like this: H2SO3 and O2. That means this one, how will you consider? You will consider as
Hydrogen.
-1, -2, and then you will cross multiply. Correct?
Yeah.
By the way, what is this called? Like H2SO4 is sulfuric acid. What is H2SO5 called?
Is it dihydrogen sulfide? No, I don't know. I'm guessing.
Okay. Actually, this is called Carros acid.
Okay.
Okay.
Mm-hmm.
Other name for H2SO5 is Carros acid. Okay. Why Carros acid? Because oxygen is taken in the peroxide form. Correct? So now when you do this, now when you try to take out the oxidation state, it will be X +2 -6 and then -2 equal to 0. So +2 and -2 gets cancelled and X equal to 6 you get.
Yeah.
Yes, or some confusion you have?
No, I get it.
Are you sure?
Yeah.
So why have I taken oxygen -2, -1? Why?
Because you are taking hydrogen in the peroxide form, so it is now -1.
See, I will redo it for you once again so that you get the concept once again. H2SO3 and O2. Okay. Here, what am I taking? We have to take out the oxidation state of sulfur. So sulfur is in which form? In the X form. Correct?
Yeah.
And X form, as in, what am I talking about? I am talking about,
Oxidation state.
yes. So see, first of all, S will be X. So this will be X. Plus hydrogen is +1. So 1 into 2 will be 2. Correct? Hydrogen is 1 into 2, which is 2. Correct?
Yeah.
Now see this one. This is in the which form? -2. So 3 into -2 will be -6. Correct? Oxygen, which one? O3 wala oxygen is in which form? In the normal oxygen form. That is -6. Correct?
Yeah.
Now, when I talk about this oxygen, I told you it is in which form? Peroxide form, -1. So what am I doing? 2 into -1. Oxygen second one, -1 into 2, which is equal to -2. Which is equal to. Then these two gets cancelled and then you get x equal to 6. This is what is happening here.
Yeah.
Okay. When I have written this directly, that means you are not doing 2 and -2. No, this is in the peroxide form. -1. 2 into -1 will become -2. This you have to.
Yeah.
Got it? And if you
Yeah.
see the diagram also, see, these two are in the normal form, but this is, see, got it?
Yeah.
Yes. So these you have to remember. Correct? Why did I get x equal to 6? Okay. Chaliye. Next one. HNO4. Can you take out the oxidation state?
Of what? Of N?
Yes. Oxidation state of N, nitrogen.
I got 7, but
Yes.
I don't know
Yes.
if the maximum is higher.
Yes, very good, very good. X plus 1 minus 8 equal to 0, which you get is x equal to 7, which is wrong because as per the rule number 6, the p block elements show the variable states, wherein nitrogen shows the variable states from -3 to +5. So this is not the maximum. 7 is exceeding the maximum. So again, the same case, we will consider one oxygen as peroxide. So now what will happen? HNO2. And this one will be in the form of peroxide. Now how will you write? I'll change the color and then do it for you. See, this is +1, this you don't know, this is -2 and this is -1. Why? Because 1 you will consider in the peroxide form. So how will you write? X plus 1. So this is X, this is +1. This will be 2 into 2. This will be -4. And this will be 2 into -1. Remember, this will be a multiplication. Okay. So this will be -2, which is equal to 0. Hence, you make it -6. This becomes 5. X equal to 5. That means in this we have 1 peroxide. Correct? Or should I do it once again?
No, I understand.
You understand? Okay. All right. All typical cases I'm telling you. Swapne, be very careful. Okay. Tell me. Chromium in Cr2O5. Very nice. Very beautiful.
Wait, can you go back to that last thing again? I just want to double check.
This one?
Yeah. +1 -4 -2. Okay, yeah. I got it. Yeah.
Got it?
Yeah.
So one more typical question, and then I will take you to rule number 9 and 10, and then we will start off with our actual oxidation one. So these are the simple ones we are doing.
Uh-huh.
Yeah.
It is so x equals to 5.
X equal to 5. Are you sure?
I don't know what the maximum is,
Okay.
but
So
I guess if we were trying to find it in with peroxide, since that's what we've been doing, then it would be Gc2O3 and then O2 will be minus 1, so we plus 1 minus 2 equals to no, this equals to x equals to 4.
X equal to 4. Okay.
Yes.
Any other answers?
That's all I got.
Okay. So Swabnip, since it's a typical case, I'll explain you one by one. Okay.
Mm-hmm.
The first thing what we'll do is we'll say x minus 10 equal to 0, which is like x equal to 10. Correct? Can I write it like this?
Mm-hmm. Yeah.
In fact, actually it shouldn't be Cr2, it should be CrO5. So that's my mistake. I did this.
Oh, okay.
I'll give you one more chance if you want to write CrO5. Sorry for this. It has to be
Okay.
CrO5, not Cr2O5.
Sure. Then it's just 8, I think.
Okay, 8. All right. Any other answers?
Wait, let me just double check.
Okay.
CO3 no, I just got 8.
Okay. So Swapnil, as per the rule, we have 10 groups. So as per the group numbers and everything, I told you the maximum oxidation state it can possess is plus 6. So obviously 8 is also wrong. So first one you tried with this one, that is CrO5, the normal one, wherein you are
Mm-hmm.
taking oxygen into the -2 form, and
Yeah.
then x equal to 10, which is wrong. Now, what is the next step which you did? You took one peroxide, correct?
Mm-hmm.
And then you got the answer as plus 8. Why? Because x minus 6 minus 2, which is equal to 0. So x equal to 8, which is also wrong. Why wrong? Because if you take one peroxide, the oxidation state is coming 8, which is not maximum. Maximum is 6, which is again exceeding.
Mm-hmm.
So what we will do, we will take here two peroxide linkages. That means two peroxides are there. How do you do it? You will split it like this: CrO, then you have O2, and then you have O2.
Mm-hmm.
That means if I have to mark them, what will I do? Cr, you obviously you say that it is x,
Mm-hmm.
which will be -2, and the rest all will be +1. Oh, not +1, it is -1, correct? Sorry, it
Okay.
is oxygen. Yeah, it is not, it is -1. Correct? So when I write it like this, it will be x -2 -1 and -1. So you have to multiply these. So this becomes 2. This also becomes 2, which is equal to 0. So x
Yeah.
equal to +6.
Yeah.
Correct?
Yeah.
I'll do this once again for you. See, what we will do is CrO5. We will write it like this: CrO, O2, O2. And the oxidation states I will mark it as, this will be X, this will be -2, this will be -1, this will be -1.
Yeah.
Then what will you do? You will multiply these, correct? So you will have X -2, -2, -2, which is equal to 0, which is equal to 0, which is equal to 6. Okay. Now, why this question is typical other than taking two peroxides is because it forms one structure which is very, very important and nice, which is called a butterfly structure. And how do we draw it? We draw it like this. See, 4 oxygen and 5th one you will draw it like this. Correct? And these two you have to link together. These two you have to link together. And these, and this structure is called butterfly structure. If I have to mark the, the values, how do I do it is, see, this one is -2, this one -2. Okay, because two these things are connecting, correct? Yes, Swapnil? Hello?
Wait, can you just say that again?
Okay. I'm saying this is connecting by 2, correct? Two
Yeah.
lines. That
Okay,
means
yeah.
this oxygen I have put here. O -21.
Yeah.
Okay. Rest all will be, this will be -1, this will be -1, this will be -1, this will be -1. Why?
Yeah.
Because -1
So
ke how many are there? 2. -1 ke how many are there? 2.
4.
So
Wait, what?
1, 2, 3, 4. So 1, 2, 3, 4. See? So two peroxide linkages. Correct? This is peroxide linkage. This is peroxide linkage. And what are the charges on chromium? It will be like this. See, it is -2. So here it will be +2. This will be +1. This will be +1. This will be +1. This will be +1. So 2 + 1, 3 + 4, 5, and 6. That's what my oxidation state is. Okay. I'll redraw it again for you. What we will do is we will take chromium. We will take oxygen. This is which oxygen? The oxygen which is showing -2, the normal oxygen. Now we will draw the peroxides. So peroxides, how will you draw? You will draw it like this and like this. Why? Because if you see -1, but how many oxygens of -1 are there? 2. So this is one side. Same way, this is one side. Oxygen, oxygen. But do you think these oxygen will remain empty? They will also have to be linked, correct? These two also have to be linked, correct?
Yeah.
Correct? Why am I doing this? See, these two are connected with chromium, but what are these? These two are also connected, no? Oxygen has 2 bonds. So it has to break, correct? One is with chromium and one is with oxygen. That's what is happening here. See, one is with chromium and one is with oxygen. One is with chromium, one is with oxygen. Correct?
Yeah.
Correct?
Yes.
So that's what I have done here. And when you see, when you split the charges, how are these charges? See, this is of -2, this is of -1, this is of -1, this is of -1, this is of -1. Correct? So what are the charges on chromium in that case? See, iska charge, this will be, how do I rub that? Somehow I can.
Control Z.
Okay, I'll redraw the structure for you. Okay, oxygen. Okay, fine. Now I'll take this one. Correct. So see, this will show +2. This one will show +1. 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 So if you add these two, 2 + 1 3, 3 + 1 4, 4 + 1 5, 5 + 1 6. This is exactly the state of chromium.
Yeah.
Yes.
Yeah.
And this structure is known as butterfly structure. Yes.
Yeah.
So here, why it is like this? Because we are considering two peroxides. See, two peroxides. These are the two peroxides. Correct, Swapnil?
Yeah. Yeah.
Okay. So you can just, take the, the equation from here, and maybe diagram you can draw it from here or even here also, but it has become little untidy. So just tell me when you have to change the slide. Okay.
Okay. Let me just draw it. And
I hope you've understood this.
yeah, I did. Okay, I drew it.
Should I change the slide?
Yeah.
Is it gone? Somewhere. Okay, so this one only you can draw, Swapna, and just make this one little neat.
No, it's not very neat. It's actually it's a little neat, but it's okay.
Okay. Shall we move on now?
Yeah.
Okay. So now, Swapnil, we will learn about rule number 9. So we've completed our 8 rules, and after 8th one, we did maximum questions. So rule number 9 says rule number 9 talks about hydrogen atom. So you also know hydrogen atom, the oxidation state will be always equal to +1. Okay. It has only one exception, that is in metallics. In the metallic state, they are in the form of hydrides. Hydrides means when it possesses the oxidation states of -1. So you will say, can you give me the example? Yes, we have NaH. See, it is with a metallic sodium, NaH. So sodium will be +1. So this will become -1.
Wait, why is the hydrogen oxygen state +1?
Sodium, Na. Which group Na belongs to? Group?
Why is the hydrogen oxidation state always +1 apart from hydrides?
Okay, hydrogen is always +1, correct?
Yeah, but why?
Like oxygen is -2. No,
yeah,
Because this is in the group, no? Oxygen is in which group? So it
It's
has
in
this value.
8.
Hydrogen is in which group?
Is in the first one.
Yes. So +1. +1 is always +1. Everywhere it is +1. Correct. Sodium, potassium. What are those? Hydrogen,
Or like
sodium, potassium. What are these? One more. I don't remember all of them. Correct. Like if you say -2. So why? Because it has all the rules. Like group 2, it will have calcium, strontium. They will always have +2. Correct. That way. So it depends upon the periodic table, like which group the metal belongs to.
But like, doesn't oxygen has like two electrons in its valence shell, right? So
yeah, 2 electrons are there. We are talking about charge.
So it has.
Yes.
Is that its charge and the oxidation state different?
Yes. Yes. Definitely different. I think you are getting confused with helium. Helium is +2.
No, I know oxygen is -2. I was getting confused with hydrogen.
Yes. So I think you are getting confused here in the helium and hydrogen, like +1 and +2.
Yeah.
Okay. Anyways, so whenever you are taking these groups, no, then obviously this is in the plus state. So what will hydrogen do? Then hydrogen takes the hydride state, that is -1.
Yeah.
That's the only exception in this. Okay, or you can say KH. See?
Yeah.
Potassium hydride, sodium hydride. These are hydrides.
Yeah.
Correct? And the last rule, let's complete these rules and then we'll finish the class. So rule number 10, the last rule says aluminium. Which group it belongs to? Swapnil, come on.
Aluminium was I forgot. Wait.
See, group 3. So rule number 3, rule number 10 is also the same. Aluminium always has +3 oxidation number or oxidation state. Aluminium will never change. Okay, it will always possess +3. Now you were asking why hydrogen is +1. So see, aluminium is +3 because it belongs to group number 3. So it depends upon the periodic table arrangement where your element.
Wait. So the